Okay, today we're going to look at graphing techniques. First thing we're going to talk about is vertical and horizontal shifting. For the vertical shift, if k equals a number, then f of x plus k or f of x minus k, when you add k to f of x, shift up k units. When you subtract k from f of x, shift down k units. Okay? Horizontal shift, f of x plus k or f of x minus k. When you add k inside your parentheses, absolute value, or your root, you shift left k units. And when you subtract k inside parentheses, absolute value, or a root, you shift right k units. So that gets kind of backwards. So let's start with use the graph of x squared to obtain the graph of x squared plus 4. If you remember, x squared looked like this. Now, x squared plus 4, so we're adding k. Adding k, we shift up 4 units. So now my vertex is there. That's all we did. We shifted from 0, 0 to 0, 4. Up 4 units. Okay, here we have the absolute value of x. And remember, that was that V shape. Now we're doing absolute value of x minus 2. So we're looking at a horizontal shift, and we're subtracting. When we subtract k inside, we shift right 2 units. So instead of 0, 0, I have 2, 0. Same shape. So let's put it all together. And the function f of x equals x plus 2 squared minus 3. So this means we're going left 2 units, which would put us here. This means we're going down 2 units, which would bring us down here. As we'll learn later, our vertex is negative 2. And I just did that backwards, didn't I? Let's try that again. Or did I? Inside the brackets, we're adding. We add inside the brackets, we shift left 2 units. No, I had it right, didn't I? So the first one would be there. And then subtracting, we're shifting down 3 units, which puts our vertex at negative 2, negative 3. The following transformation results in reflections of the graph of y equals f of x. We reflect across the x-axis if y equals negative f of x. If we multiply the whole function by negative 1. And across the y-axis if we multiply just x by negative 1. So we start out with our absolute value function. And then we're taking the negative of the entire thing. So we're reflecting across. This makes absolutely no sense because If I take this and I reflect it across the x-axis, it's going to be that. If I take this and reflect it across the x-axis, not y. There we go. Reflection across the x-axis. Okay, now we're looking at the square root function, which is this. And now we're just taking the negative of x. So we're doing across the y-axis, which is this. And if you think about that, we need x to be negative or else we're not going to get, actually, I guess we should put that over here. If we take the square root of negative x, we need x to be negative in order to get a valid solution on this coordinate plane. Okay, find the equation of the function that is y equals x squared, shifted left 3 units and down 2 units. So going back up here real quick, shifting. Shift left, it's inside, and we add. So to shift left, we're talking x plus 3 squared. Then shifting down, we simply subtract 2. Now we want to reflect across the x-axis. So we want to take the negative of the whole thing. So what? Y equals negative x plus 3 squared plus 2. Okay, find the equation of the function that is in the shape of y equals the absolute value of x, but is shifted right 4 units and up 7 and reflected across the y. So right 4 units. That means we're subtracting x minus 4, right 4 units. Then we're going up 7 units plus 7. And then we're taking a negative y-axis. So I just want the negative of x. So y equals negative x minus 4 plus 7. Okay. Given a function f of x, a new function a times f of x, where a is a constant, is a vertical stretch or a vertical compression of the function f of x. So if the absolute value of a is greater than 1, the graph will be stretched. The absolute value of a is less than 1, then the graph will be compressed. So below are the graphs of y equals x squared and y equals 1/2 x squared. So a is 1/2. Notice that the graph is vertically compressed. Okay. So below are the graphs of y equals x squared and y equals 4x squared. This graph, we're talking vertically, it's been pulled up this way. So it's vertically stretched. Okay, so now we're talking about horizontal stretch and compression. Given a function f of x, a new function f of b times x, where b is a constant, is horizontal stretch or horizontal compression of the function f of x. If the absolute value of b is greater than 1, then it is compressed. If the absolute value of b is less than 1, then the graph will be stretched. by 1 over b in both cases. So here's the thing. It's backwards. It's the opposite. So this can be easily confused. So I have the absolute value of y equals absolute value of x and y equals absolute value of 2x. What do I know? B is 2, which is greater than 1, so I'm talking compression. It's like I'm squishing it in horizontally. Likewise here, I have y equals absolute value of x and y equals 1/3, or the absolute value of 1/3 x. What am I doing? I'm stretching it out like that. So this is stretched. So, even and odd functions. A function is called an even function if for every input of x, f of negative x equals f of x. The graph of an even function is symmetric about the y-axis. A function is called an odd function if for every input x, f of negative x equals the negative of f of x. The graph of an odd function is symmetric about the origin. So determine which function is even, odd, or neither. So going back here for a moment, here we're saying f of negative x is equal to f of x. That's the case, it's even. Here I'm saying f of negative x is equal to negative of f of x. So it makes sense to test for even first. Testing for even again means replacing x with negative x. So that gives me f of negative x, which is negative x to the 5th plus 2 times negative x to the 3rd minus 3 times negative x, which is negative of x to the 5th minus 2x to the 3rd plus 3x. That is not the same equation. However, if I look at negative f of x, that means I take the negative of everything. Negative of x to the 5th plus 2x third minus 3x. Distributing this, I get negative x to the 5th minus 2x to the 3rd plus 3x. So this function is odd. Okay, so let's look at this one here and let's find f of negative x. So that's equal to 3 times negative x squared minus 5, which is 3. Negative x squared is simply x squared minus 5. It's the same. So this is even. So let's look at this one here. Let's start with f of negative x. F of negative x equals negative x squared plus 6 times negative x plus 9, which is x squared minus 6x plus 9. So it's not odd. Now let's look at the negative of f of x. I'll take the negative of x squared plus 6x plus 9, which is negative of x squared minus 6x minus 9. That is not true. So this is neither. Now, there's a trick to this. Note the exponents. We have 5, 3, and understood 1. They're odd. All of them, all the exponents are odd, so they're odd. Note the exponents. Even. Even. Note the exponents. Both. Neither. Now, you have to be careful with this trick, though, because if this said +2, it would not be odd. So that's what tells me that 0 is an even number, because this is 5x to the 0 power. So that covers this section. Have a good evening, and I will see you next time.